review of the idea first. We have two rules. One of them is called the law of sines. We do this again in trig. And the law of sines says that if I have a triangle and I label it A, B, C, or whatever letters you want, but I'm just going to use A, B, C. One of the things they do with the labeling is the side across from angle A, they would call that little a, just to say that's the side across from A. The side across from B would be here, and they would call that little b, just to say, hey, that's the side across from B, because that's how we kind of think with this formula. And then the side across from angle C, this side right here, they're going to call that little c, because that means that's the side across from angle C. So these are the kind of the labelings that we need to use here to understand the formula. Because if we label this way, here is the rule that we're going to use, or the formula. The sine of angle A divided by A is equal to the sine of angle B divided by B is equal to the sine of angle C divided by C, unless you think that I have a formula that's got like 3 different parts to it and I'm going to have 2 equal signs in one equation. That's not how we look at this. How we look at it is this. Let's pick a problem back here. Let me I may go out of order just to be able to explain this.
Which number are we looking at?
Well, I'm about to tell you that if you were listening. I'm about to tell you that. Let's look at number 12. Number 12, they gave us a figure. It looks like this. And they didn't label A, B, or C or anything. We can do that if we want to. We don't have to, though. This is the information I'm going to get. And they're telling me this is 60 degrees. How I'm going to use that formula is this. I'm trying to find x, right? That must be what they want me to do, because it says find x. So what is x across from? What angle is it across from? Or that's a 60, okay? 60 degrees. Oh, I guess I drew the example here. We'll do the example, then we'll do number 12. You're right. 60. So what I would do is I'd say, okay, I got an angle. I'm going to take the sine of 60 degrees and I'm going to put it over the side across from it, which is x. Now I have another angle. It was 35 degrees. So I'm going to take the sine of that 35 degrees and I'm going to put it over the side that's across from it, which is 12, right? So if I want to do this in my calculator, I could cross multiply. I could use my calculator. I'm going to have to here. I could cross multiply. I would have x times sine of 35 degrees is equal to 12 times sine of 60 degrees. And if I want to solve for x, what am I going to do with that sine 35 to get rid of it? What do y'all think? I could divide both sides by sine 35. That's the quickest way to do it, because I don't want to have to write down a bunch of stuff. I'd rather my calculator just spit out the answer. I could divide both sides by sine of 35 degrees, because these would cross out, right? So in my calculator, x is going to equal to all of this divided by the bottom. So I would put parentheses. Here's what I'd do in my calculator. I would put parentheses around the top because there's several things there that are being multiplied, right? So I could type in, start my parentheses, 12 sine 60 in my parentheses divided by sine 35. You can actually put the whole thing in your calculator, just close all your parentheses, and you get the answer. You can just type it in one fell swoop if you want to. All in one little deal here. You don't have to go write each of those values out. I'm getting 8 point, if we go to how many decimal places they tell us, nearest tenth. That means 1 decimal place. So I'm getting 18.11. So I would write down 18.1 would be about my length there for x. That's what that side is. X is across from the side labeled 50. So x is an angle, isn't it? So I need to say the sine of x over, what would I put on the bottom? 50, because 50 is the side across from that. You might want to look at the book. the diagram there might be clearer. Okay, so now I got another angle they gave me. It was 75 degrees. What am I going to do with it? Yeah, I'm going to say the sine is 75 degrees. And what's the side across from it? Yeah, 75. That's kind of weird. That doesn't happen very often. But anyway, in this problem, that's how they set it up. We could cross multiply. 50 times sine of 75 degrees is equal to 75 times the sine of x. All right. Now, what have I got missing here? Well, I'm missing x, right? It's an angle. I'm trying to find this angle. And do you remember that when we find an angle, we end up doing this, like, inverse sine of whatever would give me the angle? So let me show you the algebra for this, because I think it actually becomes clearer what to do when you see the algebra behind it. Yeah, I'm going to do an inverse sine to solve this eventually. So let me show you how I get there. Wouldn't I first, if I want to get x by itself, it's got a 75 multiplied by the sine of x. And I'm trying to get down to the x. So let me divide that 75 out first. Now, I'm not going to cancel that 75 degrees and that 75 out, right? One's an angle, one's a length. I don't want to cancel that out. That's not, but could I reduce 50 over 75 if I wanted to? Sure. I'm not going to here just because I'm just going to let the calculator take care of it, because I don't want y'all to get all caught up in thinking you have to reduce stuff, because that's not really the point here. So if you look at what I have here, I have 50 sine 75 degrees over 75 is equal to sine of x. X is an angle, again, right? And how do I find an angle? I know I'm going to inverse sine it, or arc sine. Sometimes it's called arc sine. So, what's the opposite of taking the sine of x, if you want to look at this algebraically? Wouldn't it be doing the arc sine or the inverse sine? Wouldn't those two functions undo each other? Like adding and subtracting undo each other? But if I do this to one side to get rid of the sine, I gotta do it to the other. So I'm going to inverse sine both sides. That's how I can undo a sine. Gosh, it's hard to read that. And when I do this, algebraically, what that means is these two things are kind of like canceling each other out. And I get x is equal to all that mess. So what I got to type in the calculator is all this mess right here to find my angle. So let's talk about how to do that. First of all, I know that that inverse sine means I got to hit second sine or shift sine depending on what calculator you're using. And you see how that opens up a parentheses? Now what I'm going to do is let's type the top in. Isn't there more than one term on the top? It's like 50 times the sine of 75, right? So I'm going to put the top in another set of parentheses. So I've got the parentheses, the sine open, then I just put another parentheses because I'm trying to be real careful that I get this in the calculator right. So inside the second open parentheses, I'm going to type 50 sine 75. And I'm going to, in the parentheses after the 75, I'll write on the board in a minute what I've typed. And then I'm going to end the parentheses for the top of the fraction. And now I'm going to hit the fraction bar, which is really the divide sign, and what goes on the bottom? 75. I don't need a parentheses for that because it's only one number, right? So then I'm going to end my parentheses. All right, I'm going to write in here now what it is that I typed in my calculator. I typed this in, sine minus 1, and then I have this, 50 sine 75. I had to put that one on because of this first parentheses in front of the, right after the sine. And then this parentheses ended the top of the fraction. And then I hit the divide sign because that gives me my fraction bar. And then 75, and then I'm going to close the parentheses there. If I were to go back over this, these two parentheses go together, right? This one is this one. And then I'll do black. This one and this one go together if you're trying to pair up, just to kind of understand how the calculator's looking at that. So now if I hit enter, I'm getting that the angle, because remember, when I do inverse sine, I'm finding the angle. My missing angle is x, and it's equal to 40. If I round to 1 decimal place, that would be 40.1, because here's what I'm getting, 40.08703, blah, blah, blah. So I'm going to round it to 40.1 degrees, because I was finding an angle. This already had a step on it. Okay, so on that angle, I had 50, and I had 80, and I had x, and I had 17. And the problem was when I went across here to build my little formula, I didn't have that side, did I? But in this triangle, don't I already know, Caitlin's right, that's a 50-degree angle. You know how she knew that? Don't all the angles in a triangle add up to 180? And if you take, first if you take 80 from 180, you get 100, right? And then if you subtract 50 more out, what's left? 50. This angle is 50 degrees. So what I can do is this. I can say, well, sine of 50 degrees, what we started with over x, that part was okay. Now look at this. I got 50 degrees over here. What's the sine of 50 degrees over 17? What is x here? Do I really need to solve this? What is x going to be? 17. I don't even have to cross multiply and solve that because these are the same thing on top, so it's going to have to be the same thing on bottom. Isn't it going to have to be 17 without doing all that math?
Yes.
Yes? Okay, so they were trying to see, if you would kind of notice that.